Okay, so I've copied from our note Euclid's Euclid's solution to finding the greatest common denominator. So really this is telling us our stopping case when b is equal to 0. And otherwise what we do is we have to, it's a recursive function where we call our greatest common denominator again, where we send in now b for the first number, and we take modulus a divided by b. So we're going to define our function as GCD, greatest common denominator. And it says in line 4 that we need to send in our values a and b. Now, I always will comment, explain what my function is going to do. Use recursion and Euclid's method to calculate the greatest common divisor. So that's what this method is going to do. And so the stopping case is reached when b is equal to 0. So I check if b is equal to 0, then I'm going to return a, because it says if b is equal to 0, then the greatest common denominator divisor is a. So I'm going to return a if I have reached b equal to 0. Else, I have to use recursion, so I'm going to return instead, to call the function again, greatest common denominator, and I'm going to send in the value b, and then modulus of a divided by b. So the modulus function in Python, we use a modulus b. And now I'm going to put down my main line, and I'll do a quick test. I'm going to want to test it a number of times, so I'm just going to say while true. Input, I'm just going to say a is equal to integer input first number, and b integer input is the second number. And now I'm going to print the common divisor for a and b is, I'll call my recursive function GCD, and I send it a values a and b. All right, so this is not going to ever end, but I just want to be able to test that. Syntax error if b is equal to 0. I often make that. If the comparisons are 2 equal signs, what is the first number? First number is 3 and 7. Greatest common, yeah, there's no greater common factor than that. If I do 12 and 4, greatest common factor is 4. Perfect. What about 21 and 9? Greatest for that should be 3. And so our function is working as expected. All right. Read the note. There's kind of, it walks through and kind of explains a little bit about why Euclid's methods works. But ultimately, what we always have to do in recursion is we need to identify what is the stopping condition. The function should stop calling when b is equal to 0. Otherwise, it needs to call itself by sending in these new values.